In this lesson, we are going to be converting polar, which is kind of a trig form, to a rectangular form, specifically complex numbers. So we're going to be taking something that's in this form, and we're going to be converting it into a rectangular form. So something here that has a radius and angle measurements, and we're going to turn it into like an a plus bi kind of a complex number. So this is your complex number. This piece, so you have your cosine theta, some pieces that will help your cause here potentially a little bit, is knowing that r cosine theta is your x, r sine theta is your y, and then r is equal to kind of a Pythagorean theorem-ish look to it. And these aren't new. These just come from if we have a circle. It's not quite the unit circle because a unit circle would have a radius of 1. So if you had any other kind of a circle and a point on that circle, you could be using these trig functions. So sine of theta would be the y value over the radius, so opposite over hypotenuse. So y over r, cosine is x over r. And then to get from these to these, I just multiply the r's over. So y would equal r sine theta and x would equal r cosine theta. So I don't have to memorize it, it's just something that we've used in the past. And then this last one is coming from the equation of a circle, x squared plus y squared equals r squared. So if you square root both sides, you're going to isolate the r. So there's a bunch of different ways to do this, that if you distribute this in, this essentially is r cosine theta. So it's going to represent your x value. And when you distribute the r into this, it's going to represent your y value. All right, so you can do it at the beginning, you can do it at the end, but this is meant to be a non-calculator. And so you're trying to figure out basically what these things evaluate to. So if it's a non-calculator, then you're going to want, I would probably draw a picture. Let's draw 300 degrees. 300 degrees is a 60-degree reference angle. And so you're really doing cosine of 60. And so I start to think of kind of the basic 30, 60, 90 triangle. Oops. And I know that this is a 1, 2, root 3 relationship on that. So if I do cosine of 60, I'm looking at 1/2. So this evaluates to 1/2. So it's going to be 2 times 1/2. Now I do have to consider that I am down in the fourth quadrant. So cosine is going to be positive, sine is going to be negative, and sine of 60 is root 3 over 2. But it's going to be a negative root 3 over 2. And then I'm going to have an I associated with that. So that doesn't go away. That's part of it, and that's okay. And then if we distribute this in, we got half of 2 is 1. And then the root, the 2 cancels with the 2. So it'll just be an I root 3. And so that is actually the complex number. So if you were to graph this and you were to graph this, they would look exactly the same. So if you were to graph that, you go right 1 and down root 3. So you would go right 1 and down root 3, and you get the exact same location. All right, so that's kind of the idea. So this radius would be 2. You could draw a whole picture out of this thing and figure it all out. There's lots of different ways to go about doing this. But if it's a non-calculator, you're going to have to know some relationships with your sides. So let's do one more. So if we had 10 cosine of 90 plus I sine of 90. So cosine of 90 is not a triangle. Cosine of 90 is from that coordinate. So cosine of 90 is the x value, so this becomes 0. Sine of 90 becomes 1, so it's 1i. And then we'll have a 10 multiplied to that. So that's just going to become 10i. So if you were to graph that and you were to make a radius of 10, cosine of 90 and sine of 90, you'd be here with a radius of 10. So you'd be looking at that coordinate. But as a complex number, you have a 0 for your x, and this is your y value, which is your non-real. So it just makes 10i out of it. All right, so that was a couple examples of converting from polar to rectangular. A lot of it is very much visual on things that you've already done in the past. You're evaluating specific angles and then distributing a radius through. That part's new. But as far as figuring out what cosine of 300 is and what sine of 300, that's not new. So you just evaluate those two pieces, distribute in the radius to both of them. Just don't forget this one has an I on it because it is going to be a complex number in the end. And then there's your final answer. All right. So that is 2 examples of polar to rectangular.